For this problem, you can see that we have a phase shift. So the first thing you want to do is rewrite this problem. This would be y equals 3 sine, and now you want to factor out the omega. So factor out a 3. You factor it out of the 3x, that leaves you with x, minus, now to factor it out of pi, you have to divide pi by 3. This is pi divided by 3. Alright, so now let's figure out the amplitude. Amplitude is going to be equal to the absolute value of 3, which is 3. The period is going to be equal to 2 pi divided by omega. So 2 pi divided by whatever we factored out. That was 3. So the period is 2/3 pi, or 2 pi over 3. The phase shift, which is the same thing as the starting point for one period, is now going to come from our equation. Alright, whatever number you have here after you factored out your omega, that's your phase shift. You have to look at the sign in front of it though. If there's a negative sign, then it's going to be a positive phase shift. If it's positive, it will be a negative phase shift. So this is a positive phase shift. So this is going to shift the graph pi over 3 units to the right. Alright, so my starting point for one period that I'm going to draw is pi over 3. And my ending point, this will be where I will stop drawing my graph, because I'll have one complete period of the graph. That's going to be equal to the starting point plus the length of the graph, which is the period. So the starting point of the graph plus the period will give me my end point, or my ending point. So pi over 3 plus 2 pi over 3, that's 3 pi over 3, or pi. So that means that I can draw one complete period of this graph between pi over 3 and pi. Now, from that interval that will contain one complete period, I can make 4 subintervals. The reason we want to do subintervals is so that we can get the significant points, the places where we have high points, low points, and cross the x-axis. Alright, we're going to have 4 subintervals. The first subinterval is going to start at pi over 3, the beginning of the graph. The last subinterval is going to end at pi. Now the way that we figure out all these other numbers in here is we take the period, look at the period, 2 pi over 3, and since we have 4 subintervals, we take the period and divide by 4. Remember, that is the same thing as multiplying by 1/4. Dividing by 4, multiplying by 1/4 gives you the same thing. Alright, so now this is 2 pi over 12, which reduces to pi over 6. Now, that is the increment, or the distance, that I want to add to my first significant point to get my next significant point. So right here, in this position, I want to put, this is going to be pi over 3 plus pi over 6. So you do need to get a common denominator to do that, which would be 6. 3 will go into 6 2 times. 2 times pi is 2 pi. Of course, this is still pi over 6. Alright, so I have 2 pi over 6 plus 1 pi over 6. That's 3 pi over 6, or pi over 2. So right here, I put pi over 2. I start my next subinterval out with I start it with the number from the previous subinterval, the last number. So pi over 2. Now I need to take and add pi over 6 to that again to get my next significant point. So pi over 2 plus pi over 6. Get a common denominator. 2 going to 6 3 times. 3 times pi is 3 pi. Alright, so I have 3 pi over 6 plus 1 pi over 6. That's 4 pi over 6, or 2 pi over 3. Start my next subinterval with 2 pi over 3. And I'm going to add again pi over 6. So 2 pi over 3, which was also 4 pi over 6, if you remember, plus pi over 6. Remember, I'm adding pi over 6 every time because that is the value I add to each subinterval. Alright, so 4 pi over 6, which is the same as 2 pi over 3, plus 1 pi over 6 is 5 pi over 6. I'm almost done. When I come to the end, this is where I can kind of check and see if I'm doing things right. So if I've added all these fractions correctly, when I take 5 pi over 6 and I add that same increment, pi over 6, I better get pi. And this is 6 pi over 6, or pi. Alright, so everything ended like it should have. So now I'm going to take these significant points and I'm going to use them to help me graph. Alright, all of my significant points are positive. These are all values on the x-axis. So I'm going to start out, I'm just going to label out some points here on the right side of the origin. The first one here is going to be pi over 3. Next is going to be pi over 2. Then 2 pi over 3. 5 pi over 6. And lastly, pi. The amplitude was 3. So we'll have a high point of 3, a low point of negative 3. Now we're graphing the sine function. We're graphing y equals 3 sine of 3x minus pi. Alright, and so we need to remember, what does the sine function do? The sine function always starts its period with a low point, or not a low point, I'm sorry, with at 0 on the y. It touches the x-axis to start. At the next significant point, we have a high point. At the next significant point, we cross. At the next significant point, we have a low point. And at the last significant point, we cross. Alright, so that is the graph of y equals 3 sine 3x minus pi. Now, let's compare what we have to a standard window of a graphing utility. Alright, so 3 sine 3x minus pi. Notice there's a lot of periods drawn here. That's because our period was 2 pi over 3, or 2/3 pi. So we should have more. So right here, this is about pi over 3. You see, it's 1. Pi divided by 3 is like 1.03 something. 1.04 something, right around there. Alright, so that's where we start. Then we have a high point, we cross, and that's where we end. If you continue to go in both directions, that's what the graph would look like in a standard window. Let's take a look at y equals 4 sine of 2 pi x plus 3. Now, I know for sure that this has a phase shift because you are evaluating the sine of something and you got stuff in parentheses. It's not just the x. You got x plus something in the parentheses. So that tells you this has a phase shift. First thing you want to do if you know you have a phase shift is factor your omega out. And the omega is going to be 2 pi. So factor a 2 pi out. That's going to leave you with x for the first term. Now, the problem with factoring out your omega with every problem is that most of the time you can't, or all the time you can't factor out like a 2 pi out of 3. So the way that you do that is you just say 3 divided by 2 pi. Whatever you factor out, you put on the denominator here. Alright, now let's figure out the amplitude, which is the absolute value of 4, so that's my high points and low points. The period, I can draw one complete graph, 2 pi divided by omega. Well, I factored out a 2 pi. So the period here is 1 unit. So I'm going to be able to draw this entire graph in just 1 unit, one complete unit. Alright, the phase shift, which is also going to be the starting point, is negative 3 over 2 pi. It's negative because there's a plus in front. You take the opposite sign of what's in front, and that will tell you whether your phase shift is positive or negative. So my phase shift is going to be negative 3 over 2 pi. My end point, or I call it the ending point, that's going to be the phase shift plus the period. So the phase shift is negative 3 over 2 pi. The period is a positive 1. So you have to say plus 1. Now I'm going to write out all of my subintervals. After I do that, then I'll show you how you can use a calculator to get some decimal approximations to help you a little bit with your graph. So let's say that we draw our 4 subintervals. I did not draw the interval for the entire graph. I'll do that right now. I'll draw it right here. The interval for the entire graph is going to be from negative 3 over 2 pi to negative 3 over 2 pi plus 1. Okay? This first subinterval is going to start at negative 3 over 2 pi. The last subinterval will end at negative 3 over 2 pi plus 1. Alright, so negative 3 over 2 pi plus what? Well, we have to come back and look at the period. You take the period and divide by 4. So the period divided by 4 is 1/4. That's what we're going to add to each significant value to get the next significant value. So I'm going to say negative 3 over 2 pi plus 1/4. I start my next subinterval with that same value and then add 1/4 again. 1/4 plus 1/4 is 1/2. So negative 3 over 2 pi plus 1/2. Alright, add 1/4 again. This will be negative 3 over 2 pi plus 3/4. And if you add 1/4 again, 3/4 plus 1/4 is 1. Alright, so now it'd be really tough to figure out where all these values were if you don't get a decimal approximation. So what you want to do, get your calculator. I will use the Windows calculator. Alright, and get a decimal approximation of the very first significant value, the starting point, the phase shift. So I'm going to say -3 divided by 2 divided by pi. Alright, so this first point is about -0.48. I'm just going to write out, approximation, about -0.48. Alright, then add 1/4 to that. 1/4 as a decimal is 0.25. You give you the same thing. Alright, so if I add 0.25 to that, I have about -0.23. Alright, so this is about -0.23. All these again are approximations, so if you add 0.25 to that, this is going to be -0.02. That's almost right at 0. Okay, so that's -0.02. This next point will be -0.27. Not negative. Sorry, we went to positive right here. That's all positive. Now we're on the right side of 0. That's positive. Positive 0.27. And then the last point, if you add 0.25 again, that's going to be about a positive 0.52. So, key point that you need to remember, these two values are negative, so they're going to be on the left side of 0. Then we start in with the positive key points. So those three are going to be on the right side of 0. And this third significant point, it's not very far past 0. I mean, it's basically right at 0. Just a little bit to the right. Okay. So let's see what this would look like graphed. And the graph that is provided on your test does have a good scale to it. It has 4 tick marks, and then it has the number 1. 4 tick marks with the number -1 on the left side. So it's a good scale provided. If you draw your own XY axis, alright, then I'm going to have 1 at 0, I'm going to have 1 right here, 1 right here. So this one's going to be about -0.48. This one's going to be about -0.23. Then we have 1 really close to 0 there. Alright. Then I'm going to have positive 0.27 and positive 0.52. All those are approximations. Now I just use the amplitude to give me my high point. So my high point is going to be 4. My low point is going to be -4. And I have to know, how does the basic sine curve look? Sine curve starts out on the axis. At the next significant point you have a high point. At the next significant point you cross. At the next significant point you have a low point. And at the last significant point you cross. So that's a rough sketch of y equals 4 sine 2 pi x plus 3. Like I said, that's the toughest problem on the test. The next one is y equals 5 sine of 3x minus pi. So the first thing you want to do is, or you notice there's a phase shift. So the first thing you want to do is rewrite the function. So this is 5 sine of 3 times x minus pi over 3. Alright, let me go back and show you what I did. I factored the 3 out, so that leaves me with x. This last term here is pi, so I can't factor a 3 out of that. The way that I adjust that is I divide it by the 3 that I'm factoring out. Now, I can tell that the amplitude is 5. The period, 2 pi divided by whatever I factored out, so 2 pi divided by 3. The phase shift is going to be my new starting point. I have minus pi over 3, so a minus in front gives me a positive phase shift. So I'm going to start at positive pi over 3. My ending point, I'm going to end at my starting point plus my period. So I'm going to start at pi over 3. My period gives me the length of my graph. So if I'm starting at pi over 3 and add 2 pi over 3 to that, that'll give me where my graph's going to end, which is 3 pi over 3, or just pi. So I know that one complete period can be drawn between pi over 3 and pi. Alright, now you want to come up with these, or formulate the subintervals. 4 subintervals for the graphs of sine, cosine, secant, and cosecant. Alright, we know we're going to start at pi over 3, and we're going to end at pi. Now, to figure out what I add to my first significant point to get my next significant point, you take your period and divide by 4. Now remember, dividing by 4 is the same as multiplying by 1/4. We always do that to get the value we add to the first significant point to get the next significant point. So that would give us 2 pi over 12, which is pi over 6. So I could take pi over 6 and add that to pi over 3. That'll give me my next significant point. So if you need to get a common denominator, do all that with your fractions, do that, but pi over 6 plus pi over 3 is going to give you pi over 2. And so we start the next subinterval with the last significant point, add pi over 6 to that, get a common denominator of 6. That would be 3 pi over 6 plus 1 pi over 6. That's 4 pi over 6, which reduces to 2 pi over 3. 2 pi over 3, or 4 pi over 6 plus 1 pi over 6 is 5 pi over 6. Now here's where we can check ourselves and make sure that we've been doing things right. 5 pi over 6 plus 1 pi over 6 is 6 pi over 6, which is the same as pi. So that kind of tells us that we're going in the right direction. Now we have significant points at pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, and pi. So when we draw this, that's going to be the points on our x-axis. Alright, so we're going to make our scale. So the first point here, that's where I'm going to start. That's pi over 3. The next significant point is pi over 2. The next significant point is 2 pi over 3. The next significant point is 5 pi over 6. And the last significant point is pi. Now, you need to recall the basic shape of the sine curve, because this is a graph for sine. Alright, so here is where I start. My high point is going to be 5. My low point is going to be negative 5. And sine always starts on the x-axis. It's not shifted up or down. So I start on the x-axis. The next significant point I have a high point. The next significant point I have a low point. Is that right? No. Alright. Cross the x-axis. The next significant point I have a low point. The last significant point I cross. Connect the dots with smooth curves, and you have your graph. If you want to adjust your axis, your x-axis, to be like the way on the test, just know that it's going to be compressed big time. You're going to want to draw the entire graph between pi over 3 and pi. Alright, now this is a cosine graph. Notice there's a phase shift. So I need to rewrite this. I want to start out by factoring out a 3. That's my omega. That's going to leave me with x plus. Now, to factor 3 out of pi over 2, I say pi over 2 divided by 3. So pi over 2 times 1/3, that's pi over 6. Alright. Now, from this equation, it's easier to get all of my information. The amplitude is the absolute value of 4, which is 4. The period is 2 pi divided by omega. Omega is what we factored out. That's going to be the 3. The phase shift is going to be the starting point. Look back here and see we have plus pi over 6. So that means we're going to have a negative phase shift. Negative pi over 6. That's our starting point. Our ending point is going to be the phase shift plus the period. Our starting point plus the length of the graph. That's what that is. Now, make sure that you're careful when you add these two fractions together. If you get a common denominator of 6, it's going to be negative 1 pi over 6 plus 4 pi over 6. So that's 3 pi over 6 or pi over 2. So we're going to end this graph at pi over 2. One complete period for this graph will be from negative pi over 6 to pi over 2. Alright, so we make our 4 subintervals. We know that the starting point is negative pi over 6. The ending point, pi over 2. To figure out what we add to each significant point to get the next significant point, you take the period and divide by 4. So 2 pi over 3 divided by 4. Dividing by 4 is the same as multiplying by 1/4. So that's going to give me pi over 6. So I'm going to add pi over 6 each time to each significant point to get the next significant point. My first significant point is negative pi over 6. Negative pi over 6 plus pi over 6 is 0. 0 plus pi over 6 is pi over 6. Pi over 6 plus pi over 6 is 2 pi over 6, which is pi over 3. And 2 pi over 6, or pi over 3 plus pi over 6 is 3 pi over 6, or pi over 2. So that's the check to let you know that you've been doing this right. Alright, this is a cosine graph. My amplitude is 4. So I can do a rough sketch real quick. High point's 4, low point's negative 4. I have one negative key point, so I need to make sure that on the left side here, left side of 0, I do have a negative pi over 6. Alright, so that's a significant point there. The next significant point is 0. The next significant point is pi over 6. The next significant point is pi over 3. And the last significant point is pi over 2. Now this is the cosine graph. This is y equals 4 cosine of 3x plus pi over 2. Alright, so the basic cosine graph, we remember, starts at a high point. So we're going to start at a high point. Next significant point we cross. Next significant point we have a low point. The next significant point we cross. And the last significant point we have a high point. Now connect these points with smooth curves. Probably not the best graph, but so connect the points with smooth curves. And there you go. That's a rough sketch of y equals 4 cosine 3x plus pi over 2. Alright, on number 19, this is matching. So what you're going to do on this, you're probably just going to want to write the number on the graph. Alright, so the 4 graphs that are provided will match up with the 4 equations. 2 of the graphs are sine graphs, 2 of the graphs are cosine graphs. So you need to know that the basic shape of y equals sine of x looks like this. The basic shape of y equals cosine of x looks like this. So you can match those 2 graphs up pretty quick. You can see number 1 is C and number 2 is A. Alright, the 2 that you're left with are y equals negative sine of x and y equals negative cosine of x. That's going to flip the graphs. So take the graph I have up here for y equals sine of x and flip it. That gives you B. Take the graph I have up here for cosine of x and flip it. That gives you D, as in delta. Number 20, the last problem on the test, is number 20, and we have 2 sine graphs and 2 cosine graphs. The only difference is between this problem and the last problem is we do have to worry about amplitude and period here. Well, the main thing is that we can figure out the period for each one of these. The amplitude is the same on all four graphs. Here's my four equations. Alright, so now if we look at what's in front of the x, you see two of them have a 1/2 in front and two of the equations have a 2 in front. So for the two with the 1/2 in front, their period, both of those, is going to be 2 pi divided by 1/2 or 4 pi. So that's going to stretch the graph tremendously. So if you draw one complete period of 4 pi, just know that, it's going to be stretched out. Probably just going to be just enough to fit on the graph. For these other two, the period is 2 pi divided by omega, which is 2. So the period here is pi. So it's going to be compressed. There's going to be a lot of periods drawn on the graph. Alright, so that's what I would use to help me. If you look, B and C are both stretched out pretty far. So B and C is going to have to be either y equals -3 sine 1/2 x or y equals +3 cosine 1/2 x, because the graphs are stretched. So let's identify the cosine graph because it's positive. Remember, cosine starts at a high point. So B starts at a high point at 0. So B is y equals 3 cosine 1/2 x. Well, that leaves C to be y equals -3 sine 1/2 x. But how could I tell if I didn't know that the other one was what it was? Well, the -3 flips the graph. So instead of going up first, you go down, up, down. So it flips the graph. If you look from 0, that's where that would start. That's the way I drew that. Then going down from 0, that would be C. Alright, the other two graphs are y equals 3 sine 2x and y equals 3 cosine 2x. So A and D are those two. So the way that you could do that is I would find the positive one again. So C at 0, do we have a high point at 3? We do for D, so it has to be D. The only graph left then would be A for the first one.